And welcome back. As we continue our cosmic journey through our own solar system, let's go ahead and discuss ring and moon systems. So when we start talking about moons and rings, the first thing you have to understand is that all four giant planets within our solar systems are accompanied by moons that orbit about them, kind of like planets in a miniature solar system. Now, of course, when referring to moons, these are, of course, referring to bodies that are captured within a regular orbit around said planet. Now, nearly 200 moons are known in the outer solar system. In fact, there are too many to name individually or to discuss really in any detail. Now, astronomers also anticipate that we will find additional small moons in future discoveries with better tools, technologies, and maybe even future visits to these planets. And speaking of visits to the planets, we've also discovered a fascinating variety of rings around each of the Jovian planets. So Jupiter, which a lot of times you don't see pictured with rings, does have a ring system. Same thing goes, of course, for Saturn, Uranus, and Neptune. Now, before we had the Voyager missions, even the largest of the outer planet moons were mere points of light within our telescopes. However, in less than a decade, once we started launching probes out into space, we had close-up images of many of these moons, and these moons then became more of individual worlds for us, with unique features and peculiarities. So when we start talking about the moons of our solar system, we can see a lot of them represented here in this image with Earth for scale. The rings and moons of the outer solar system, you have to understand, are not composed of the same materials as the mostly rocky objects in the inner solar system. So they have a slightly different composition to them. And we should expect this because since they formed in regions of lower temperatures, these were cool enough so larger quantities of water ice were available as things like building materials. So most of these objects that are out here in the outer region of space that are moons also contain dark organic compounds that are mixed with their ice and rock. You compare that, for example, to the moon, which is just mostly a silicate and iron type of composition. You're going to see a very different composition when you start exploring moons such as Titan. Now, as we start talking about the orbits of the moons themselves, roughly 1/3 of the moons in the outer solar system are in a direct or regular orbit. That means that they revolve around their parent planet in a west-east direction and in the plane of the planet's equator. However, the majority of the moons that we observe are irregular moons that orbit in a retrograde or an east to west direction, or they have orbits of high eccentricity, more elliptical than circular, or they have a high inclination, which means they move in and out of the planet's equatorial plane. Now, these irregular moons are mostly located relatively far from the planet. For example, if you look at Jupiter, the Galilean moons are a lot closer, whereas a lot of these more irregular moons are further out. The reason for this is these moons were probably formed elsewhere and were then subsequently captured by the planet that they now orbit. So let's talk about Jupiter. Jupiter has 95 known moons and a very faint ring. These include the 4 large moons, Callisto, Ganymede, Europa, and Io. These, of course, were discovered by Galileo and are referred to as the Galilean moons. Now, the smaller of these, Europa and Io, are about the size of our moon, while the larger, Ganymede and Callisto, are actually about the same size as the planet Mercury. Now, most of the moons, as I just mentioned earlier, around Jupiter are much smaller. The majority of the moons around Jupiter are in retrograde orbits that are more than 20 million kilometers from the planet and are actually likely captured asteroids, but because they've fallen into a regular orbit around Jupiter, we consider them to be moons. So let's look at the Saturn system, but Saturn has a lot to talk about, so let's first talk about the moons of Saturn. Saturn has 146 known moons. The largest of the moons, Titan, is almost as big as Ganymede and is the only moon with a substantial atmosphere and lakes or seas of liquid hydrocarbons, which is typically things like methane and ethane on the surface. Now, Saturn has 6 other large regular moons with diameters between 400 and 1600 kilometers, a collection of small moons orbiting near or in the rings, and many captured strays, kind of like those of Jupiter. Now, one of Saturn's smaller moons, Enceladus, has active geysers of water that are actually being expelled out into space. So it actually has giant eruptions that expel water out into space, and it cools down. Some of it will actually condense back down onto the moon's surface. Now, Saturn, of course, has its very distinctive ring system. The rings of Saturn are probably one of the most impressive sights in our solar system, and these rings are broad and flat with a few major and many minor gaps between them. Now, the rings are not a solid feature, but rather better to be thought about as a huge collection of icy fragments which kind of all orbit around the equator of Saturn. Individual ring particles are composed primarily of water or ice and are typically in range from the size of a ping pong ball to that of a basketball. So you have a nice good variety of chunks here. There are of course larger ones and smaller ones, but this is where most of the collection of objects in Saturn's ring system look like. Now we would talk about the Uranus system. The ring and moon itself of Uranus is tilted at 98 degrees, just like the planet itself. Remember, Uranus sits effectively sideways in its orbit. Now, the Uranus system consists of 11 rings and 28 currently known moons. The 5 largest moons are similar in size to the 6 irregular moons of Saturn, with diameters of about 500 to 1600 kilometers. Now, discovered in 1977, the rings of Uranus are relatively narrow ribbons of dark material with broad gaps in between. Astronomers actually suppose that the ring particles are confined to these narrow paths by the gravitational effects of the numerous small moons, many of which we haven't actually glimpsed, because remember, Uranus is a lot farther away than Jupiter and Saturn, so it's a lot harder for us to gather some of the information. And finally, we have the Neptune system. Neptune has about 16 known moons. The most interesting of these is Triton, a relatively large moon in a retrograde orbit, which is unusual when we start looking at larger moons because typically they tend to follow in a more normalized orbit. Triton has a very thin atmosphere, and active eruptions were discovered there by Voyager in its 1989 flyby. Now, to help explain its usual characteristics, astronomers have actually suggested that Triton may have originated beyond the Neptune system as a dwarf planet, much like Pluto, and it was eventually captured and held within its orbit. Now, the rings of Neptune itself are very narrow and very faint. That's why you don't often see them depicted with Neptune. However, like that of Uranus, they are composed of dark materials and thus are not easy to see. Again, because they're not easy to see, you don't have light reflecting off them, so it makes it harder to observe.